Hello everyone. In this video we are to see another vapor refrigeration system. It is Vapour Absorption Refrigeration System. Before going to that, let us see an essential concept. In thermodynamic concepts, energy can be classified into two: low-grade energy and high-grade energy. Low-grade energy is a form of thermal energy in various sources which can get converted into other forms, but the portion which gets converted is less, and it is also difficult to convert. Often it gets wasted too. So when we convert solar energy in a system into electricity or something like that, the efficiency what we have is only 23%. The maximum is 23%. Even when we try to generate electricity in a thermal power station with the help of fuel, the efficiency what we have is about 30%. Even the internal combustion engines where we use fuel to generate mechanical work, even there the efficiency is around 30 to 35%. So here we have. Now when we look at low grade energy, if we try to convert it into high grade energy, the portion what we convert is less and it is difficult as well, so often it gets wasted. Meanwhile, when we look at high grade energy, it is actually obtained from low grade energy. More low grade energy is used to get high grade energy. Example, electricity. It is easy to convert high grade energy to low grade energy. If we try to convert high grade energy to low grade energy, even we can convert the entire thing, something like this. If we have this much quantity, almost entire thing can get converted into low grade energy. So it's good to see like this, but the problem is it is very expensive. It is effective to convert. Almost everything can get converted, but it is expensive because we use huge quantity of low grade energy to convert it into high grade energy. So now coming back to our concept. In the previous video we saw that vapor compression refrigeration system, and it runs in electricity, that is a high grade energy. And if we have a system, refrigerating system, which can run in low grade energy, that will be an added advantage for us. Yes, of course. This vapor absorption refrigeration system can run in low grade energy. Now we look at, in vapor absorption refrigeration system, the topic itself says that it has vapor and it is being absorbed. Vapor is being absorbed. So here we have a refrigerant and a solvent. There are various types. We have two popular things. One is ammonia in water and water in lithium bromide. So here this is the refrigerant. Ammonia is a refrigerant, water is a solvent. In the other case, water is a refrigerant, lithium bromide is the solvent. Now we choose this one. We look at ammonia in water, which is a popular one. Ammonia in water. Before going to that, we must know something about ammonia. Ammonia is a gas and it boils at minus 33 degrees centigrade. And it has a tendency to absorb heat from its surrounding. That's very important for us. That's one of the important qualities of a refrigerant. And it is actually a colorless gas, but it has a pungent smell. Even if there is any leakage, we could find out with the help of the pungent smell. Then it has an interesting property. It readily dissolves in water. It readily dissolves in water, but it varies according to the temperature of the solvent. Yes, it is. When the water is cold enough, it absorbs or it dissolves in the water. Meanwhile, if the same water which has ammonia is heated up, it gets liberated. So that's the thing here. Gas in atmospheric conditions, it is colorless, it has a pungent smell, it boils at minus 33 degrees centigrade, can absorb heat from surrounding. That's a very important thing. Dissolves in water but varies by temperature. As I told you, dissolves well in cold water. If the water is cold enough, it can get dissolved easily. But the same water, if it is heated up, it will get liberated. Another one interesting thing is, it is not that interesting. Actually, it is non-compatible with copper. Non-compatible with copper. So we need to be bit cautious while we use the accessories. We cannot use any copper fittings in this case. Okay, now we move on to the working of the vapor absorption refrigeration system with the help of the layout. When we look at this one, this is almost similar to vapor compression refrigeration system. Almost similar. What the thing is, in the previous case, we had a compressor which is run by electricity. Now we say that this can run in low grade energy. Now we can replace the compressor. That is an interesting thing. Here we have the layout of vapor absorption refrigeration system. When we see this, we have a condenser, we have receiver, then expansion valve, then evaporator. All these things are common even in a vapor compression refrigeration system. But in that case, we have a compressor in addition to that one, which is run by electricity. But here, we don't have that. Instead, we have an absorbing system. Let us see how it works. Initially, let us consider the entry for the evaporator. Here we have low pressure, low temperature liquid ammonia. Once when it enters into the evaporator, it can abstract the heat from the evaporator, and meanwhile it gets converted to vapor. So it will become low pressure, low temperature vapor ammonia. So once when it comes here, it extracts the heat. This is the region which is to get refrigerated. So it extracts the heat here and it comes out as ammonia vapor. Now what we do is, we make use of these characteristics of the ammonia. We dissolve it in a water. This is called absorber. We dissolve it in an absorber. Once when we have the absorber cooled, that will be an additional advantage for us, because if it is cold enough, the dissolving property will be more. So we have an absorber with the help of some cooling unit which can maintain the temperature of the water low enough. So this vapor will get dissolved. Now we pump this aqueous ammonia solution to another thing where it will be maintained at a high temperature. So it is pressurized and it is taken here. Actually we use a pump here, which is a small pump which will not consume much energy. But the most important thing is, once when we come here, it is a generator. In this generator, the aqueous ammonia solution is heated. Once when we heat, it can liberate, because we know that the ammonia will get liberated once when the water gets heated. The interesting and the important thing is, we heat this with the help of low grade energy or the heat energy. In industries, oftentimes we waste the heat energy. If we can use that heat energy to generate this vapor ammonia, that is our need. So if we can use waste heat to heat this, our work is done. From this case, here we will be able to generate vapor. And once when it comes, we have a rectifier actually. It's actually a dehydrator. Once when this generator heats up, there will be mostly ammonia, but a portion of water too can pass through. So here, this region will separate the water and it comes back to the generator. So beyond this, we will be having pure vapor ammonia. Pure vapor ammonia will pass on. Meanwhile, from the generator, we have lean solution. Once when this process continues, the lean solution will come back to the absorber. Here we need to have high concentration, so the lean solution can be taken back to the absorber. Now we continue with this one. So here we have pure vapor, that is the refrigerant. Now we pass it on to the condenser. Once when the pure vapor pass through the condenser, that will get liquefied. So here we can use air to circulate, so that we will be able to condense the refrigerant and to convert it into liquid ammonia. That can be stored in a receiver. And now we pass it on to an expansion valve, as we did in vapor compression refrigeration system. Once when we pass it on to the expansion valve, the pressure reduces a lot. Okay, so low pressure, low temperature liquid at the entry of the evaporator. Here is where we started. So it's a cyclic process. It continues. So in this manner, the liquid ammonia can get converted to vapor again. Meanwhile, it will extract heat from the evaporator and the cycle continues. And in addition to this, here we have a heat exchanger. This is actually enhancing property. Once when we have a hot lean solution from generator, we try to take it to the absorber. We know that the heat what it carries is not useful over there. But the pumped aqueous ammonia solution is heated here. So we transfer this heat to this one. So meanwhile, this gets cooled and comes back here. Once when this is pumped, this can get the heat and it can come here. So it is an advantage for us. This is the working of vapor absorption refrigeration system. When we look at, this is the most important thing. This system can run in waste heat, which is often wasted in industries. If it is available, we can make use of this system. That is the most important advantage of the system. And if you look at the other things, this is a system which can be built to huge size. Vapor compression refrigeration system is good actually when it is for a smaller size. This system can be built to even thousands of ton capacity. In the order of around 3,000 ton of refrigeration can be constructed. And it doesn't have much moving parts. So what will happen? We will not be having much maintenance. Compressor is the heart of vapor compression refrigeration system. Here we don't have that. It is not necessary. So we don't have that much maintenance. Once when we try to make huge compressors, it will be robust and we need to have strong foundation. It will occupy huge space, but this doesn't take that much space. So here it is. Can work on low grade energy, can be designed for huge capacity, low maintenance, less space consumption. But this system cannot be made to suit for a smaller size unit, as it is not that economical. Okay, so this is about the working of vapor absorption refrigeration system. It's an interesting thing. We'll continue the air conditioning in the upcoming videos. Thank you.